stuff that we're having exit the vertebral column. Okay? So those are going to be our peripheral nerves because they go to the periphery of the body, not just the skeletal muscles. What else has to be innervated in the periphery outside of my spinal cord?
Cardiac muscle?
I got cardiac muscle, my organ systems, which have what kind of muscle? Smooth. Remember, we have 3 types of muscle: skeletal, cardiac, smooth. Okay? Everything's going to be innervated. The system that serves that area is different. Okay? We'll get into that. So, I'm going to have my 31 pairs. When we look at the structure of the spinal cord, when you look at this, and I think they have some pictures, but they try to represent it on this right here. It's going to have all these little grooves. Now, longitudinal, long, okay, and on both sides, anterior and posterior. There is a groove that's running through the middle, the anterior median and the posterior median. Remember all your terminology from part 1? We divide it into regions. The regions that it's divided into: cervical, thoracic, lumbar, sacral, coccygeal. Those are the regions that we have for the spinal cord. We find in 2 places enlargements. We've got one in the cervical region, one in the lumbar region. A huge enlargement at the cervical region. Guess what? These are going to be nerves for what?
For your arm.
For my arm and the lumbar region, my leg. So you've got these 2 enlarged areas so that those nerves can feed the upper and the lower extremities. We have what's called the cona equina, which Brian already referred to, and then the medullary cone, or conus medullaris. All right? Love the terminology. That's going to be an area on the spinal cord that tapers to the lumbar enlargement. When you go on break, just come up here and take a peek at how they've got the structures made. Okay, and I'm pretty sure it's in your textbook also. So really cool anatomy to it. The pictures that they're kind of showing you in the book, they're letting you know cervical, thoracic. Each region is going to have a certain number of vertebrae. Okay? So, cervical, thoracic, lumbar, each one has a certain number of the vertebrae that are present. The segments, see how they're kind of, they took like a section of it and broke it down, showed us the nerves that are exiting the part that is under bone, and how that nerve is connected, that's letting us know a segment. Yes, no, maybe. Okay. So segment, 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 segment. So you would have like C2, C3, C4. Okay. You would have these segments under those vertebrae that are found. Just like everything else that we have learned up to this point, this is going to have connective tissue wrapping. The meninges. Heard of these? How? Meningitis. Do what? Hey. Hanger? Okay. What?
It'll give you a headache mainly because you're dehydrated and like meninges and fluid sac, and so there's not as much fluid in there that you actually put pressure on.
You do get dehydrated, and the CSF would be low. So, yeah, I just have never heard it that way. But, yeah, so, okay, hangover. Hangover. Did I learn something new today? My day is not. The meninges. We mostly hear from them. For the most part, we mostly hear them for and so the meninges, we mostly hear about them because of meningitis. And when we hear itis, okay, that's, you know, ending to the term, all right, what's that tell us? Inflammation. It's inflamed. Meningitis can be either viral, bacterial, in origin, okay? It can be deadly. There's this one now that I keep seeing the commercial for. Make sure your child is immunized because it actually comes on so quick, like in 24 hours. Yes. I just remember it showing, like, you know, the mother and the son and all that sort of stuff. It's kind of sad that it comes on that quick and it can be so deadly so quickly. Now, the meninges, we're going to have three, okay? We're going to have an inner layer, middle layer, outer layer. Even though this very special tissue, all right, the nervous tissue, is encased in bone, okay? That first layer, when we look at the brain and the spinal cord, that first layer is going to actually be able to follow the actual contours of the tissue. That is how close it's going to be in protecting that beautiful tissue. So, we're going to have our dura mater, arachnoid mater, the pia. The pia is the one that's just covering the structure for every single groove. The outermost layer, that one's going to be our dura mater. So we've got the one that's innermost, one that's outermost. In the middle is called the arachnoid. It's termed arachnoid because arachnoid means spider, and it actually looks like a spider web because of all the blood vessels. It is very highly vascularized. So these meninges, they're going to be protecting, they're going to be offering a little bit of squishiness, if you want to say that. But what that's going to be able to do, if I have my brain and it's encased in bone, all right, we know it shakes around. Well, it's not a lot, because we don't want that. But we know that it can shake in that cranium, all right. Having those meninges gives some protection, but not all the time. A very sharp blow, okay, can make that tissue bang against the cranium, which is not good. Concussion. Okay? So those meninges do give some, protection. And under normal circumstances, this is good. We've got the bone, we've got the tissues, we've got a little bit of fluid, we've got the protection that we need. In the area of the arachnoid mata, which is going to be to the dura, which is to the outer, which is connected to the bone, we're going to have our place that's going to be called the subarachnoid space. In that area, we're going to find the cerebrospinal fluid, the CSF. These meninges have these layers over the brain and the spinal cord. As the spinal cord tapers, so do those wrappings. And those wrappings will eventually come to a terminal point, what we know as the terminal phylum, and they will end at that point. The purpose for having this type of structure, what does cerebrospinal fluid do?
Transfer the electrical impulses from the brain.
Well, the fluid itself moves around, circulates, and it's going to be a way for lubrication, okay, keeping it kind of moist, so to speak. The cerebrospinal fluid is going to be very similar to blood plasma. What do we find in blood plasma? This might be what you were thinking about for those electrical impulses. It carries my electrolytes. It carries nutrients. So if I have the fluid washing over these tissues, I have the ability to keep those tissues nourished. Now, what is the only molecule that brain tissue can use as food? Glucose. It can't use anything else. Glucose. In part 1, did you all talk about how the body can use materials if needed to make glucose to serve the brain? Okay? Because the way that the body is going to utilize glucose, it's going to feed the brain first, organs second, and then everything else. So we're going to have all of that in that cerebrospinal fluid, and that fluid gets to wash over the spinal cord tissue and the brain tissue. Keep it clean, help to get rid of waste, help to bring in nutrients, all these different activities that the CSF can do. We know that, well, one of the things now, if you're